Alright, good morning everybody. I'm out here on the bridge in my backyard. I've got a creek that runs right through my backyard, so we actually have a bridge in the backyard, and I thought it would be a perfect place to spread out and give you this introduction to our Geologic Maps lab, our Geologic Map of Washington. This is our first geologic map that we're going to use in this class, and we'll use a few more, but we're just getting our feet wet. Not in the creek though. So a geologic map. What is a geologic map? We've dealt with maps already that tell us where things are. We've got little symbols that mean roads and you know, different symbols that mean different things. Topographic lines, maybe to show us the contour of the ground. We've dealt with all of that. A geologic map is exactly what you might think it would be. It is a map that shows the geology of an area. Specifically, it shows the geologic structures, so faults, folds, we know about those. You'll find faults and folds on a geologic map, and you'll find rock types. Normally, a geologic map, usually the rocks that it shows are going to be what we call bedrock. And bedrock is a word that we use for rock that has formed in place. If the rock is in the same place where it formed, we would call it bedrock. So, for example, outside of Mattawa, when we look out the north window of my classroom and we look at the Saddle Mountains, we see those layers of basalt lava rock that make up the Saddle Mountains. That is the bedrock of that area. That is the Saddle Mountain bedrock. Now, some places, we have stuff on top of the bedrock. We might have gravel on top of the bedrock, and we might have soil on top of the bedrock. And a lot of the time, that stuff isn't shown on a geologic map. Sometimes it is, sometimes it isn't. Depends on what the author of the map is trying to show. So anyways, another example near Mattawa. At the base of cliffs, sometimes you have your basalt lava rock cliffs, right? And then at the base, there's kind of a slope of loose rock that's fallen off of the cliff. So that would not be considered bedrock because it has detached and has moved to the bottom of the cliff. It's still made of the same material. In our case, in Mattawa, it's still made of the same material as the bedrock, but it isn't bedrock because it's not large block rock that is formed in place. Okay, so you probably can't see very well on this video, and I will, when I'll include some high-resolution photos of different parts of this map for you to use. I'll also provide the PDF document of the whole map, but I know that a PDF this big, when all you got is an iPad, a PDF this big, it's really hard to zoom in very far. So I'll include some good photos for you too, and I should be able to include everything that you need. So just a couple of introductions to this. You can probably see on the video the state of Washington, the shape of Washington state, and some colors. We've got some blue right here and some green over here, and this is some pink, kind of tan and lighter tan. There's a little bit of yellow right there. There's some kind of mustard colored stuff over here. Sort of a teal color over here. Each color on a geologic map, each color is a symbol that represents a certain type of rock. So the dark purple is a different kind of rock than the light green. Okay, well that's cool. How do I know what kind of rock it is? A really important part of using a geologic map is getting familiar with the key. There's symbols galore all over a geologic map, and until you're really good at using them, you need to be able to go to the key to know what those symbols mean. So, if I wanted to know what this dark purple rock is right here, I'd go over to my key, and it's organized by, you'll see this on the close-up photo I give you guys, but this is at the top is unconsolidated sediments, sedimentary rocks, volcanic rocks, intrusive rocks, meta-sedimentary and meta-volcanic rocks, that means metamorphic, metamorphic rocks, amphibole facies, and higher. You don't need to worry about that. All of this stuff down here is metamorphic. So all I need to do if I'm looking for these dark purple rocks, find out what this is, and come over here and find that color. And here it is right here. And it's got this silly name that says MZPZU. Mesozoic to Paleozoic ultramafic rocks. Okay, it's not super specific, but it does give me a category of, or a family of rock types. So cool. I'll talk a little bit about the names, because on the map too, there's also that MZPZU. You can't see it. I can barely see it because it's dark purple. But each of these units also has a letter, combination of letters that names the rock type. Okay? It's always going to start with a capital letter. And that capital letter is going to be going back to our geologic time scale. That's going to be our geologic period that it's from. So if it's quaternary, it's going to start with a Q. If it's tertiary, it's going to start with a T, and so on and so forth. And then there's some lowercase letters. And those lowercase letters are an abbreviation that should describe what the rock unit is. If it were a Triassic mudstone, the symbol might be a capital T lowercase r for Triassic, and then MS for mudstone. So over here is your key of geologic units. Also notice it's always organized with the youngest on top. That's original horizontality and principle of superposition, right? Principle of superposition tells us the youngest units form on top of older units, so that's the way they set up the key as well. Oldest stuff's going to be at the bottom, youngest stuff's going to be at the top. Within the categories, within the little families, so within the volcanic rocks block here, youngest to oldest. Within the sedimentary rocks, youngest to oldest. A couple other things, some more symbols down here in the lower right-hand corner of the map. There's some different lines that show types of faults and what they mean. There's some lines that show folds. Then there's some highways. And I think that's about all you really need. Like I said, I'm going to upload a bunch of high-resolution photos of this thing to go right along with this video and the form for you to fill out, the page, 2 pages. Basically asking some simple questions about geologic maps, just making you use the map. Of course, this is a lab, so you've got to, we'll have like a week to get it done. If you have questions, get stuck, need help, definitely reach out, because that's what I'm here for. Cool. I hope that you guys are having yourselves hope you had a good weekend. Hope you're having a good day. Hope you have a good week. I miss you guys tremendously. What else? Other news. Oh, I started putting together a virtual field trip for you guys that will go to all of the field sites that I was going to take you to. It's going to take me a little while to get that done, but I'll be pushing those out, pushing those videos out as I get them done. So, stay healthy, stay safe, and I will see you guys on the next video.